After 3 years, I'm done waiting for your show to film an episode about me. It stings. I'm shocked. I'm moving on to better things. Ciao or adios or however they say bye in Greece or whatever.
What's up and welcome, fellow wanderers. I'm Cara Crouse, and I am so happy to have you here on 300 Seconds of Science. The search for immortality begins at the start of documented history, inscribed in the stone tablets of the Epic of Gilgamesh. Utnapishtim told Gilgamesh, who was the king of Uruk, that eternal life would be found in coral on the ocean floor. Turns out, over 4,000 years later, we discovered there was something to the tall tales on those stone tablets. In 1988, German marine biology student Christian Sommer conducted research with Italian spongiologist Giorgio Bavistrello. Sommer would snorkel near the ledges of Portofino, Italy, and gather tiny hydrozoan organisms in plankton nets. Hydrozoans are invertebrates that look either like a coral or a jellyfish, depending on where they are in their life cycle. Within the collection Sommer returned to the lab was a strange little species known as Turritopsis dohrnii. He observed the reproduction pattern and was blown away by this weird phenomenon. This Turritopsis wouldn't die. Instead, it aged backwards. The Turritopsis dohrnii was named in 1883 by German evolutionary biologist August Friedrich Leopold Weismann, the developer of germplasm theory. Germplasm theory states that the inheritance of genetic traits in multicellular organisms can only be done through germ cells. Germ cells include gametes, cells that fuse during sexual reproduction, like egg cells and sperm cells. This means that offspring of multicellular organisms can't inherit any traits that aren't in their biological makeup. According to Weismann's lecture titled On Inheritance, the formation of germ cells in asexual organisms is similar to gemmation. That is, instead of cells pulling apart through fission, the splitting of one being into two, a new organism starts as a growth on or inside the parent before splitting off to live independently. An asexual organism, in theory, could produce genetically identical copies of itself. And that's exactly what the Turritopsis dohrnii does. Its life cycle starts like most hydrozoans as free-floating planula, though unlike most hydrozoans, this bad boy is exclusively found in the Mediterranean Sea and waters surrounding Japan. The planula settles and develops a polyp colony that sticks to the seafloor. Each of these polyps and jellyfish that grow from a single planula are genetically identical copies. The polyps gather in a branched form, and jellyfish pop off the polyps to start their free-swimming life. When the jellyfish reach sexual maturity, they are able to reproduce and begin the reverse aging process. If the jellyfish experiences stress or assault, gets old, or gets sick, it can alter the state of its cells through transdifferentiation. Transdifferentiation is the process by which one mature cell transforms into an entirely different mature cell without having to grow up again. By turning their old cells into a new type of cell, they are able to reverse aging, return to their polyp form, and start over. This process can be repeated forever, making this jellyfish biologically immortal. But in nature, they're likely to die due to circumstance, so they'll probably never get to return to their polyp phase. Each of these cells contains everything needed to create an entirely new organism, but somehow only pieces of this are used once the cells become differentiated. We're still trying to figure out how these cells can reverse and what exactly it is that allows them to repeat this process indefinitely. Imagine 300 seconds of science of seconds, 300 seconds of science of seconds? The Turritopsis holds a sea of possibilities. The regenerative potential for themselves is just a drop in the ocean of what it could mean for humanity. Thank you for sharing 300 seconds of your day with me. Don't forget to smash our subscribe button on YouTube, follow us on Twitter, like us on Facebook, and give us a heart on Instagram. This was Cara Crouse with 300 Seconds of Science. So go out, enjoy life, and stay curious.
This program was produced by ZTV at the University of Akron. To find out how you can make Emmy-winning media, visit the UA School of Communication online. ZTV. Make media. Make a difference.